Good afternoon, everybody. Abhilasha madam,
Yes,
can
madam.
you start now the program?
Okay. Okay, madam. Thank you.
Okay, ma'am.
Good
Thank you.
afternoon,
Ma'am, please
everyone.
continue.
Okay. Good afternoon, everyone. Welcome to the fifth and final day of the Faculty Development Program on Recent Trends in Renewable Energy, organized by Internal Quality Assurance Cell of Regent Education and Research Foundation Group of Institutions. I am Abhilasha Sao, Faculty of Basic Science and Humanities Department, and with me is Mr. Shabyasachi Mukherjee, Assistant Professor of Mechanical Engineering Department. We are honored to be your host for today's concluding session. Attendance in all sessions are compulsory to qualify the certification. Today, we are privileged to have with us Dr. M.K. Loganathan, an a chief reliability consultant of Crimson Energy Expert Private Limited, formerly Dean of Engineering and Technology and Director of IQAC, the Assam Kaziranga University. He is an accomplished researcher and extensive experience in both academic and industry. Dr. Loganathan completed his PhD from IIT Delhi and pursued postdoctoral research at Changdong University, Taiwan. His areas of expertise include infrastructure reliability, renewable energy, and coastal environmental management. With a rich background in sponsored research, industry consultancy, and supervising master in doctoral students, Dr. Loganathan has made notable contribution to the field of renewable energy, with numerous peer-reviewed publications to his credit. Today's session will focus on application of AI and ML in renewable energy, a topic of immense relevance as we navigate the future of sustainable power generation. Now let us welcome Dr. M.K. Loganathan to take over the session. Sir, please.
Yeah, thank you so much for the introduction. Am I audible to all of you?
Yes, sir. Yes, sir.
Great. So once again, thank you so much for my colleague Dr. Sudeep Basak for inviting me for presenting this short presentation, you can say, to the faculty fraternity of the Regent Education and Research Foundation, Kolkata. Thank you once again for giving time. I like to before we start, like just to throw some light on my experience, how I started my career, because you may wonder that I am from industry and I have been working for even institutions till now, of course. After my PG program in mechanical engineering, I joined Hindustan Motors as a production engineer. Then I went to join Mahindra and Mahindra as again production manager, section manager. So during this tenure of my experience with these two companies, is I got exposed to the practical implication of engineering concepts. Of course, almost I spent 10 years time, right after my PG. Then I traveled the journey, right, to obtain actual knowledge, the practical knowledge, right? So what really we study in the classroom and what should we do in manufacturing, production, in design, right, in materials. So that was a big opportunity for me, and 10 years I was there. Then I wanted to do my research. So without any research idea and background, I wanted to do research. So the one way to take up research is to take up a teaching job, right? So I opted for my teaching. Anyway, I left my industry and then I joined some engineering colleges in Kerala as assistant professor. So that was my starting point of my teaching career. So for 5 years, I was working with some institutions in Kerala, but I could not do anything in research. So no idea of doing research, what to do, what not to do. But I was doing good in teaching. So I was very happy to continue my teaching job as a teacher, right? But moreover, above all, we have to contribute, in towards research that will definitely build the institution. So that contribution from my side it was zero during that particular 5 years time. Then I was looking for research opportunity, and I attended some QIP programs of FDP like this, right, which was conducted by various institutions all over. So I started applying. Just I got some, admission like for attending the programs, some leading institutions like IITs, NITs, etc. So that was my, exciting period of getting into research, right? So the FDP, I'm just why I'm sharing this, right? So how the FDP plays a critical role in developing your career, right? So that 5 years I learned what is research actually. I got introduced to research, right? And I started developing a research interest in me, right? So I thought that it was the right time for picking up the research career, right? So after 5 years of my experience with the teaching job, I cannot say it's a faculty. Faculty means everything. So as a teacher, I just opted for my research career later on. Then I went to do my PhD in IIT Delhi. That was the beginning of my career. So 5 years I was there in IIT Delhi. I could do a little research. So I came up with some research background, right? Then after gaining the research experience, I had a teaching experience, I had industrial experience, and then that added research experience. So these are the different skill sets what actually the teacher wants in teaching engineering students at this point of time. Right. So then I started my professorships at faculty. Right. So is a combination of teaching, research, and kind of administration activities. So I started my career with the Assam Kaziranga University as an associate professor. I was heading the department of mechanical, and I was also heading the School of Engineering and Technology sometimes. I grown up like administrator. I could do little, contribution towards research as well, and I could do some projects of sponsored by ACT and DST and all. The way I could do something in this particular renewable energy sources. So that's how I took up this particular, the research come teaching in this particular renewable energy sources. So I was there for some times, and then it in something sparked, right? So I should go for some higher skill oriented courses or something like some job should I take up to enhance my research further, right? So I was not satisfied with that. Then what I did, I just went for my postdoctoral research in Taiwan. So that was really a good opportunity. It was a rare opportunity after a long time of experience and getting older. After getting old, right, it is getting difficult to get into some research organization as a research fellow, what you call the postdoctoral research. So I could carry out my postdoctoral research in Taiwan. And for 2 years I was there. I could get chance to travel around the Asian countries and the other part of Europe and all. regarding this research assignment, and I could participate in some international conferences. So that was the motivation I could gain as a postdoctoral research. Then I came back and I joined the same university. I could contribute little towards the things what I learned right during my course of postdoctoral research, and then and the research in IIT and all institutions, etc. Right, so it could help me to expand my networking. That is very important, right? So I could get a lot of people all over world, right? So good connection with me. So I'm a small guy, of course. So I could get into a big network wherein a lot of experts and eminent professors and then people from industries just as a part of that particular team. Right. So then I just then afterwards in 2020 I became my IQC director, and I wanted to take up that particular academic teaching learning process to some different level. So I was given that assignment. So during my tenure as IQC director, that I really realized, I literally realized that the importance of conducting this kind of FDP, right, faculty development program. FTP should be a continuous process, right? So the changing attitude of people. I had my experience in my previous university that where I was IQC director. When we conduct some program on some basic topic, like for example Excel programming, all right, so introduction to MS tool or whatever, right, introduction. So that time the mostly faculties think that I learned something what I am going to learn here in FDP. Always the thought process of any faculty members to be like this, right? Many things. It has been changed later on. That is different, ball game. Then, so the realization of that FDP was not to up to a certain expected, a level or for the faculty, right? So the faculty is to be what is expected to be, how the faculty is to be by the institutions, how should they deliver to the managing the complete, teaching and learning process or etc. So later I did that, and I continuously started organizing FDPs on various topics. So in order to enhance the faculties, that is very important process what we do in IKC, because students are to be taught. For teaching them, we should be experts, not like a simple teacher. We should be expert in the particular subject, right? We should get exposed to practically. We should get into research advances in the particular topic. So we have to have a kind of comprehensive skill set, uh, so that we can perform well in this particular faculty career or job or whatever, right, in institutions, so that the institution can be built up in different level. Right? So that is my introduction. So this introduction, I would like to just emphasize the FDP of this particular, for the faculty fraternity. Now, after that, I also worked as a principal of some university in Jaipur, what you call Suresh Ganviar University. And by the time I got an opportunity for serving for our nation, so I'm just doing my job. I'm just contributing my knowledge towards nation building, you can say. So now presently I am associated with the Crimson Energy Experts Private Limited as a chief reliability consultant. The reliability is a kind of different engineering which includes the statistics, right? The life extension of any engineering component or a product. So we are into that particular life extension program of engineering equipments. So that is my current profile, right? So how we are going to discuss this particular topic, A&ML. The A&ML has taken over the world of engineering, right, by storm, particularly in renewable energy sources. Of course, we are in the middle of the journey where we have employed this particular topic, A&ML. So it's very common topic. It has become very common topic nowadays because the A&ML, everything is on your hand, right? So if you just open a chat GPT, everything is your hand. So anyway, since we teach the subject and we do research in this, we should at least know the basics of AI and ML and application. What are the different areas where we can apply this AI and ML, and what are the different renewable energy systems existing, right? Or so we will just quickly go through the overview of this particular topic, which is AI and ML in renewable energy system, right? Um, why we go for renewable energy sources? Of course, we have to, satisfy this Paris Agreement. So that aims to limit the global warming relative to pre-industrial baseline. What is a pre-industrial baseline? It was 90s, right? 1900 era. So during that time, how the pollution was, how the temperature was on the plant on this particular planet, right? So it should be around, for example, the average temperature should be around 30, less than 30 or whatever, right? Now the average temperature has gone, right? So the Paris Agreement is an agreement which was formulated by the countries, world communities, right? Around 195 countries have the part of UN. They come up and they formulated this particular, is a part of this particular agreement, holding the increasing temperature of global average temperature. It should be below 2 degrees Celsius, which should be above the pre-industrial levels. So what was the temperature during that particular pre-industrial era? And pursuing efforts. So we should not only keep ourselves within the holding the increase in temperature, but also we should pursue the effort to limit the temperature increase to 1.5 degrees Celsius, right? That is again above the pre-industrial levels. So recognizing this particular aspects, this will help reduce the risk and the impact of climate change. The another aspect is that sustainable development goal. So as we know that the world nations are working towards achieving this particular set of goals, which is known as SDG. Around 17 goals are there. So most of the goals are linked to these particular renewable energy sources. So if you are able to develop an efficient and effective renewable energy source, we will be able to achieve most of the goals of this particular SDG. So these are the very important, aspects we should know before we develop any kind of, renewable energy sources for meeting our requirement, right? So these are the things, the preliminary things we should know. And okay, so these are the key directions to achieve those particular, set of 17 goals, right? Um, Reducing direct costs in production of equipments, right? So we should be able to reduce the manufacturing cost, design cost, material cost of any renewable energy sources or the equipments or the system, right? Or the running costs, operation cost, etc., right? And the system should be able to increase the sustainability, right? So it should be sustainable. It should not harm the environment or the ecosystem in by any way, by means of its design or the manufacturing process or whatever, right? Even after the equipment is used, after maybe 15 years, what it happens with our vehicle, automotive vehicle, right? So we have to recycle that used equipments or sometimes. So that recyclable, the future should be there, right? With this particular renewable energy sources and equipments, etc. And the energy conversion is very important point, because when it is to be sustainable, it should be energy efficient. The system should be energy efficient. For example, you just took case automotive car vehicle, right? So just to now we have a boom, EV is coming up. So EV is partially renewable energy source, but not fully, right? So because EV is not going to be sustainable for some time, some reasons that, as you know, that because operations is fantastic, is fine, but the raw material side, it just we have to damage the ecosystem, so it cannot be called as a sustainable technology, right? So the EV has come, but EV operational efficiency, energy conversion efficiency is better than even uh, IC engine vehicles. So what that fossil fuel engines are not that much efficient when you compare with the EVs. So at least we could be able to achieve that particular energy efficiency in case of EV. That is the main reason that the EV is now getting popular in the market. So these are the key directions by which the innovations and the technological evolution should happen towards achieving the renewable energy sources, harvesting, etc. Right. Right. So then, yeah, just I put this the different types of renewable energy sources, right? So you can categorize into six major group, right? Hydropower, of course, you know the water is being used to convert the you can say the potential energy is converted into a kinetic energy, right? By using a different kind of turbines, etc. So the conversion of fluid energy, right, into electrical energy. And the wind, as you know, that wind is converted, wind speed, wind energy is converted into electrical energy. The wind turbine, the wind movement is utilized, wind's velocity is utilized. And solar, again, so we harvest the solar intensity, right? So the solar light is directly converted into electrical energy. So with the help of PV cells and all, so that you know that. And bioenergy is another important area where we lack, right, in harvesting the energy. Right? So bioenergy means use waste, right, to convert the biogas into waste. In the process of conversion, you produce biogas, that what you call the methane, right? So that methane is a kind of fuel which can be used for domestic application, even for generating electricity, etc. Then marine, yeah. So you can also use the energy created by the tide of sea, right, and the wave of sea, etc. So wave energy can be converted into electricity, and then geothermal, which is very least. Okay, it is not much explored, you can say, because of a lot of challenges going on, right? So geothermal means you're just extracting the heat from the underneath of the earth, right? So the heat is stored underneath of the earth, right? So a lot of energy is available under earth, so we have to tap it out. So that we are facing a lot of technological issues, so that's why it is not much explored. But the solar is very well organized renewable energy source what we have in India. So in 2022 you can see that 67 gigawatt power produced. That is the capacity of installed solar power plant in India. Now you see that in 3 years time it has come up to 105 gigawatts of solar energy. So almost it is 40% of the growth. So we can even predict that it will go on, and mostly most of the you can say the states will be going towards producing solar energy because of a lot of benefits, right? What the solar energy provides when you compare with the other energy sources. So secondly, the wind is also significantly improved from 40 to 50, around 50%, but there are a lot of challenges again. So when you compare with solar, wind is not so cost effective, you can say that. And also the lot of the equipment, manufacturing equipment, the another challenge. And then operations, the big huge wind turbines, it involves a lot of elements, mechanical and electrical electronics elements, right? But whereas in solar you have all static equipment, and the failure and the maintenance operational cost is very low. Of course, the efficiencies to be questioned as far as the solar cell is concerned. A lot of research has been taken up, right, to improve the efficiency of the solar cells. That is a different story. But anyhow, the solar is gearing up to take the maximum contribution of our renewable energy consumption, right? This. And then hydro again is a capital is very high. You need a big capital, and it's a large project. When you compare with these two, solar and wind, it's still this progressing. It needs water resource, so government is putting a lot of money on this also to to harvest the energy from the water. The other renewable sources like biomass, small hydro, and waste to energy is a very small plant where you can put a waste and convert energy. Like domestic waste can be used. You can have your small incinerator, like which can be used to convert um, the bio waste or the food waste from the domestic, right, and then electricity can be produced out of that. So these are the present or the installed renewable energy sources, right? The Indian government, and we are not talking about the how the world is moving around. Of course, when many countries are moving ahead of India in harvesting renewable energies and all, but we'll see later. So there are challenges in renewable energy setup, right? So the socio-economic and the technological challenges still persist in developing, in manufacturing, in designing, in maintaining and operating that particular renewable energy sources and also. So we have to address all the challenges and what are the techniques or how the A and ML will take up these challenges, right? In addressing all these challenges, that is what is going to be discussed in the subsequent slides. So these are the different challenges like land acquisition, site availability. So you have to do some survey of land, right? Otherwise, you cannot put the wind turbine, you cannot put the solar. So the reasonable intensity should be there. And solar irradiance should be there, right? And what you can say that wind velocity should be there. Enough wind velocity should be enough to generate a reasonable amount of power. So the site selection, land acquisition is another important area. Still, the challenge is persisting, right? You cannot go for an agricultural land or wetland. You cannot put your plant in wetland, right? That is against the law of ecosystem. And then the grid and integration and infrastructure, right? So the existing grid mean where you produce electricity and distribute through the different power lines and reaches to the ensure that the power reaches to the customer, right? So that particular grid. Now the grid is conventional grids are existing when you produce electricity from various sources, right? You need to upgrade the grid capacity, or we have to upgrade the grid technologically, right? So that is again lagging in the present scenario. And financial and investment risks, of course, there is always a financial risk and investment risk is there, because when the company wants to invest money on this particular renewable energy source, they always see the revenue and the profit generated, of course, right? So if it doesn't do well, if it doesn't look good, there is always the scarcity of investors in this particular area. Unless the government invests, so the private players will be um, very nominal in number, right? And the regulatory and policy uncertainties, it is happening with, even you can see that the state government, the central government, they go changing the policies and then regulations, etc., with respect to the renewable energy setup and all. So again, so there are the challenges to get to the regulations of the government, right? So the investors have to think about this. There is again challenge. Energy storage limitations. So whatever the energy produced, we have to store it. So you can see that the research is going on rigorously in developing battery system, right? So presently we have a lithium-ion battery which is widely used in powering you can say EVs and all, but there are a lot of issues with this. So the multiple battery technologies are being developed, so in order to address that particular area. So there is a limitation of this particular uh, sources, right? So energy storage limitation. And then technology and manufacturing gaps, still it is there. For example, if I have a lot of heat under my earth, right? I want to tap it out, so we don't have a proper drill, right? Not with the good technology, right? So that way I can tap the heat from the underneath of the earth. So there is a problem. So you have the solution, but you don't have the manufacturing capacity, right? So in order to tap the potential of that energy. And skilled workforce shortage is there. You know that there is a manpower is very important, right? So the technologically the things are going up. The we talk a lot about the employability of our students, right? So still the industry faces that particular skilled workforce shortage. It is there. And environmental and societal impact, of course, in order to put your wind turbine, you have to see whether it affects the environment. Of course, it has got some impact on this particular environment, right? Um, so and the solar also, so it will occupy the plant, it will disturb the the habitat of other biological species like birds and all. So definitely it has got some impact on the ecological system. So societal impact, again, another important problem what we go through in India, right? So these are the again challenges, and the demand supply mismatch is there always, right? Of course, these renewable energy sources are really variable energy sources. You can say that as and when you get wind, as and when you get an intensity of sunlight, you can be able to produce good amount of electricity. That is there, and the demand again. So if there is a demand, you'll not be able to feed your demand, right? So that production of electricity will be lower. So there is a problem again. And then integration with industry and urban planning, of course, you have to incorporate this particular technology with the urban setup. But still, many countries have been successful in achieving this particular the integration, right? So these are the things which we have to keep in mind when we develop some model, right? Some A and ML model to address these particular challenges. So how the MI and AL models are going to be exploited in solving these issues. So demand fluctuations, as I already told you in my slide. So always there is inaccurate weather forecasts, right, which affect solar and wind output. It happens actually. And unreliable demand prediction that always lead to grid imbalance. So in order to address this, what we provide this A&ML solutions, forecasting and predictive model. You can predict the power generation, or you can predict the wind speed, right, based on the past data. So that is what is happening using this all AI model and all, right? The AI model can forecast the solar irradiance, wind speeds, and then cloud cover and etc. Right. So accordingly, the model can predict the electricity demand using the past and historical data, right? And grid instability. I would like to just to confirm whether you the slides are being changed. Can you just to confirm, any one of you?
It's in the 8 slides, sir.
It's fine, right? So it shows that I'm sliding it, right?
Yes, sir. Yes.
Yeah. So the grid instability mean it happens due to intermittent renewable supply. Again, so as I mentioned, the solar and wind, right? It, these are the variable, energy sources, right? So they supply the energy intermittently. So because of that, the grid becomes unstable. You can say the unstable, right? So the grid will not be able to supply the energy to the consumers, right, during even peak hours, or sometimes if you have a good amount of electricity intensity of light, and you have very good speed of wind, then you will be able to produce more amount of energy, and they can be able to supply or excess energy or whatever, right? So there is always imbalance in this particular you know grid setup. So the AML helps to optimize the grid operations in real time. Of course, it collects various parameter and it gives you the output. So how much energy to be produced. Accordingly, you can make your energy setup, right? So that is another important, area of application of this particular AI and ML. And reduced operational reliability. So what do you mean by reliability? Reliability is an aspect, right? It is the probability. Reliability means a probability that an equipment is able to perform its intended function, right? So wind turbine should be able to produce the expected amount of power, right, as per that design, right, as it is designed, right? So it should not fail. So in order to meet that particular functional aspect, the machine, the wind turbine should not fail, right? So the failure makes, or the failure brings tremendous cost in operational, you know, uh, total cost of the operation, etc. So the equipment failures and inefficiency in operations, obviously the equipment fail, right? Inherently it will fail, right? Because if you use it for 10 years, there will be a failure of mechanical component, right? It's subject to various stresses, mechanical and thermal stresses. Electrical motor will burn out, right? And then electronic cords may go away, right? The transistor ICs may go up because of the the intensity of the heat of the or continuous operation. So the components are subjected to various stresses, of course. So reliability is an important issue in operating this kind of renewable energy equipments, right? And another important thing, the maintenance should be conducted on the equipments. So manual inspections are very important. You have to conduct a periodical inspection, right? Of 6 months once, or yearly once, or weekly once, right? As we do it for our automotive vehicle or car or bike or whatever, right? So we do have to have this particular kind of particular manual inspection, right? So what is the challenge actually? How to do this kind of inspection, maintenance, right? So how to predict when the machine will fail? So everything is based on some mathematical prediction. So what you call in A and ML, you can go for a predictive maintenance model. You can develop a predictive maintenance model through collecting the sensor data. IoT is there, so this is a completely IoT. You collect the data and try to analyze the data, and you see any changes in that particular data, or the data of operating parameters, right? So if there is any degradation in the data of the operating parameters, definitely you will have to have some action. You have to take some action to maintain that particular machine. So in this way, A and ML, tools are used extensively in order to conduct a proper maintenance of a machine. Storage and battery issues. I mentioned this. We have limited capacity of storage, right? In inverters, you can say inverters which store energy when getting from the renewable energy sources. So the cost is high. Of course, the battery cost is high, and it's not sustainable. As I told you, the lithium-ion battery has got a lot of environmental impact. So this is again another challenge, right? You cannot be able to store energy more than what is specified or what is produced by the solar or wind turbine, etc. So you need to have a huge amount of the huge number of battery cells, right? So they, again, it's a big challenge, right? And also battery failure happens. Mean what will happen if the inverter fails? You have the inverter or the standby UPS, right? And if the UPS fails, so what will happen? The main line is gone and UPS failed. Then so there is no any standby to USB, right? UPS, sorry. So in that case, you have to have some smart battery management system, right? How the battery fails, different parameters are to be monitored. Or our algorithm, our software tool should be able to diagnose the health condition of the particular battery system, right? In advance, it can give you some hint. Oh, that particular battery is going to be down maybe after two weeks time. So please take action. So what we will do, we will simply replace the inverter. So that kind of predictive models, the battery management system, is being widely used, which are developed by this A and ML model, right? And also you can forecast the energy storage of that energy battery usage and generation. Okay. And issues related to the site selection, of course. This also I mentioned in the earlier slide. Selecting site for setting up the renewable energy project is really a critical task, a recurrent task, you can say, right? So it takes a lot of time, and if you do it manually, there will be a number of errors, or you could say that. So you will not be able to land, you will not be able to zero on appropriate site for putting up your project. And also, you can say that you cannot harm the people. Also, you cannot occupy a land wherein it is being used for harvesting agriculture or grains and or etc. Right? Or also wetland, right? So there is a production of wetland. So, of course, in this case also you have your A and ML models, right? So you have to have the parameters, all these, whatever the variables or the parameters associated with the site selection, right? Planning and site selection can be given to this model. A&ML model will be, and you can easily optimize the site, the selection of the particular site, right, for setting up the renewables. And the financial risk, of course, uncertainty, how much return on investment time, and there is a market risk. And you can see that nowadays the share prices of renewable energy share, you can say there is a share called renewable energy share. The company share, the companies of the shares of those companies which produce the electricity through this renewable energy sources, right? So again, it is a big challenge, but still in present market, you can see that there is a growth of the share values of the companies which are into producing electricity through these renewable energies, right? So here also you can apply this particular A&ML model, right? And the sustainability issues, so there is a difficulty in accurately measuring and reporting emissions. Yeah, of course, as I told you that EV doesn't produce any emission, of course, but directly it doesn't produce any um, emission. But the battery is too heavy, and because of the weight of the battery, the weight of the EV goes up, right? And it puts a lot of pressure on the tire, and the tire wear and tear will be higher, and it directly or indirectly affects the emission, right? So there are different kind of emissions coming out of the kind of EV, right? So the sustainability issues also to be taken care of, right? How, whether the particular energy system, like for example biogas plant, right? So it also produces um, um, some nitrogen oxide, so that is harmful, that spreads into environment, and then definitely it is harmful for the people who inhale it, right? So this kind of emissions are to be tracked and monitored, and this is possible with the help of A&ML model. So AML can also evaluate the compliance with the sustainability targets and ESG. ESG means environmental, social, and governance score. Every organizations has to have very good score, right? ESG score. Country should have ESG very good score. Even our domestic, our house should have very good ESG score. What that is that is going to happen in future. Adaptability, so low public awareness, of course. Adoption of rooftop is still not picking up. If you know not all the houses are having rooftop solar smart. So again, there's a lack of information, and how much energy is consumed domestically, so we don't monitor properly. There is an energy meter, but the consumption varies from month to month, you can say, from time to time. So there is a lack of real-time insight, real-time monitoring of the domestic energy consumption is not existing, right? So in this case, we have AI powered apps available, that is possible. So these AI powered apps can help you to monitor the energy consumption. You can cut down the consumption, and you can streamline, you can regulate the usage of various appliances at home. So again, A&ML can be a very effective tool in doing this particular job. So I think you must be knowing this basics of A&ML, right? So AI is nothing but a program that can sense, reason, act, and adapt, right? So it's a simple computer code, you can say. And that the functionalities, it makes matter actually, right? So that can sense, reason, act, and adapt. So that is a kind of a human intelligence which is executed by a machine. Then machine learning is a subset of artificial intelligence. So it's a kind of set of algorithms whose performance improve as they are exposed to more data over time. So machine learning is a very important tool in exploring performance optimization of various renewable energy sources. And the deep learning is again subset of machine learning models that mimic the human brain function. So we just move ahead, right? So using deep learning, you can do the function of human. So it will work like a human, brain, right? And then now we are in the era of generative AI. You have ChatGPT or in many other AI tools, generative tools. So what does it do? It works based on this deep learning mechanism, but it creates the content. It can create whatever the outcome you want, right? A text or graphs or images or whatever, right? So that is what you call generative AI. So these are the basic, different classes of an ML model. So I put a small example of machine learning algorithm, the basis for machine learning algorithm. How do we go about it, right? So just to take an example of linear regression, which is very commonly used a statistical tool, right? Linear regression. I think all of you must be knowing about regression, right? You can do regression of two parameters, right? I have put on graph here. You can see that I just plotted the graph between wind speed and then power produced by that particular wind turbine, right? So the plotted graph, and you see the line linearly growing, right? So this is what you call linear regression. So with this you can develop with the available data. I have around 7-8 data point. I just plotted the line, and you can develop your own equation, linear equation, right? Which is nothing but very basic equation, y equal to ax plus b. So you can just formulate the equation for this particular parameters, right? Two parameters, and which are two parameter, you can say here. And you can develop the equation, and with the help of the equation you can just predict the value of the independent variable. Here we have two variables, right? One is a dependent variable, which is in y-axis, and then independent variable, which is in x-axis. So x-axis variable is wind speed, which is independent of anything else, right? And y-axis is power produced, which is dependent on this particular independent variable, right? So power cannot be produced unless there is a you can say wind speed, right? So wind speed should be there significantly, so that you can be able to produce the power, right? So that is how we define the variables. So you have to define the variables before that. So you can predict the value of dependent variable later on, right? So this algorithm can be used for predicting the power produced, right? So using this, linear regression model. So this is one good small example, right? Similarly, you can develop different sort of equations to optimize the performance of the engineering system, right? So I will not discuss more about different types of AI and ML model, but I'll just go through different applications only, right? So you can see here how the AI and ML models are utilized in various area of renewable energy sources. So I put one good slide over here, right? So this is what you call artificial neural network, ANN model in solar energy production, right? So you can forecast the power production, right? How much power is produced out of the installed solar panels which you have installed. So that's what is project over here. What are the different inputs, right? Time, historical power information, and meteorological forecast also to be added here as an input. So as far as this ANN is concerned, this is something like, you are just stimulating the function of a brain, right? So in a brain, what are the different neurons, how the neurons behave, right? So what are the different layers in neurons, right? So the input layer, there is an input layer, there is a middle layer, hidden layer, or what you call so hidden layer, and then third layer is nothing but output layer. So there are different layers in our human brain. So how the information is processed, right, in our human brain is simulated by this particular artificial neural network, right? So you just give the input value to the input layer, and you define the transfer function, and you put some weight for each parameter, and the transfer functions will translate the output to the output layer, right? So that is output of this particular model, which is forecasted PV power production, right? So there is a simple example which I have given you here to predict the solar energy which is produced installed. Yeah, so different area of applications of solar energy can be explored, right, with the help of this particular AI models. So you can go for PV sizing. You can select the size of the PV panels and all, and you can also use AI model in cyber security, right? So you are using different models, different software programs, and and communication systems in your energy, right? So there should be always a cyber security, right? It can be active or passive. And fault detection, as I mentioned you earlier, that the parameters are to be monitored and check whether the component is being degraded. Accordingly, you have to take a maintenance action, right? So maintenance and forecasting, as just we discussed in the previous slide. Then wind turbine, the same case. You see the challenge in wind turbine. The man is standing on the big wind turbine, right? He has to climb up maybe around 50 feet or more than that, right? The height of wind turbine, and do perform a different sort of inspections, right? So this kind of activity can be averted by a demo model. So simply what you have to do, you put some sensors at different locations of the components which are failure prone, right? So you put the sensors and you try to monitor the parameters sitting at the control room, and you'll definitely get some hint of degradation of those product by just simply monitoring the operating parameters, right? And the inspection is over, so just you go and replace the component. So inspection can be done with the help of a demo model, right? So this kind of a complex engineering system. Yeah, the same thing for wind energy. I think I have put it for wind energy over here. So you take the parameters like a wind speed, wind direction, air humidity, air temperature. Sorry. And you put these input parameters to the input layers, and then hidden layers will process it with the help of transfer function. Will get the output, which is nothing but a forecasted power value of wind turbine installed, right? So I have again put the similar slide for various domain of wind turbine system. Sorry. You see this AI design of wind turbine blade, which is very recently designed by some UK company. The first AI designed urban wind turbine, which offers around 7 times more than the efficiency of the existing wind turbine blade. Can you imagine this? So this is the outcome of AI model, right? So it can be very fast, it can be very accurate, it can be very precise, right? So when you compare with the activities carried out by human manually, so that is the power of this AI, which is going to take this world heavily, right? So these are the parameters, input parameters: blade length, shape of the material blade, right? The different curvature, and what is the material used for making this blade, and the tip speed ratio, the speed of the tip, right? The ratio of speed at tip and the wind speed, right? So that is a ratio, tip speed ratio, what you call. So these are the parameters to be given for training your AI model. And then AI in lithium and battery system. Of course, as I told you, you can check the health of the lithium and battery, right, by using various sensor, and you can collect the temperature, current temperature, operating temperature, and you can also understand the state of charge, state of health. So accordingly, you can predict the remaining life of the particular battery. So this AML algorithm can be of great use here. AI techniques in bioenergy, of course, anaerobic co-digestion. This is biogas. So what I mentioned earlier, that methane production. So the biogas can be optimized. The production of biogas can be optimized. Biogas production can be affected by the temperature, right? The temperature in which you process the biomass, and then pH value of that particular biomass, pH value, right? So it should be alkaline, right? Not too much acidic. So you have to be able to control all these parameters in order to get optimized amount of methane production. So here also you can be able to use this AI in demo model, right, to create optimized production of methane. Smart grid is very important and a very popular area which is now coming up. The grid, the power distribution line. It's a conventional way of distributing the power from a single power plant, but now you are just going to explore various power sources and how you are going to integrate the power, incoming power, which are coming from various power sources, right? So integration, transmitting, and you should know which source is producing high power and which is low, and what is the demand at particular location, what is not, where there is no demand in some different location, and the other side, client side, right, consumer side. So there is a complex network actually. So in order to manage a network, this conventional, what you call national electric grid is not sufficient, right? So we have to go for a smart grid. So what does it do actually? Smart grid. Smart grid has got a communication channel which connects each node in this particular grid, right? So every point, like the production unit, the consumer unit, and transmitting unit. So different sources, different transmitting line, transmission line, you can say, and different clients, right? Different domestic or different cities are together connected, right? It's a very complex grid system. So we need to have a smart grid which uses an extensive communication network. Here you have to use a ML model extensively, right? So there's another important area of application of AI model, right? Okay, that's it. And just here, I put some techniques, right? So these are the different AI techniques employed in renewable energy application. I collected these techniques from a recent research paper, which did a survey of application of AI tools in renewable energy sources or the energy sector. So I'm not going to discuss in detail about each technique, but I think you need to select the appropriate technique for your area of application. That's it. Right. So most probably, what I observe from the application of various models, a demo model, different problems will go for the selection of different AI tools, AI techniques, right? So all depends on the problem. For example, there is a tool called CNN, right? Convolution Neutral Network. It is not written over here, but it is a part of ANN. That particular tool is used for processing images, right? So images and all. If you want to process your numerical data, it is just to go for the AI techniques like a support vector machines and the ANN, etc. Right? So these will help to have a kind of analysis which will help you to analyze the linear relationship between various parameters, right? Linear or non-linear relationship also. So there is another problem which is go ahead of this particular linear regression model. Right. So we have to select based on our application. I am not going to discuss more in depth because you have to find out the application of your area and you need to select the technique accordingly. So AI applications are exhaustive nowadays. Again, I put the informations which I collected from various research papers, right? So the first model, ANFIS, what do you call adaptive neuro fuzzy interference system, right? So fuzzy is used here, right, in this ANM model, which has been used to track the power of PV system. So it rapidly adjusts to variation in irradiance and the temperature without producing steady state oscillations. This particular model has got some weakness, of course, because it is rapidly adjusting, but the accuracy is not so good as far as the model is concerned. But in order to increase the accuracy, you can incorporate or you can integrate 2-3 AI tools. For example, you just integrate ANN along with this ANFIS. So the accuracy is around R squared value. You see the R squared value. R squared value gives the you can say the accuracy of this particular numerically processed models, right? The models which process numerical data set. So R squared is equal to 0.999 something. So that is a very good accuracy of this particular hybrid AI techniques and all. So if you go on hybridizing the techniques, the accuracy level of model will go up. That is one thing you keep it in mind when you select a particular model for your application. And back propagation neural network is another model which was used to model the diffusive solar radiation prediction. I put the number over here so that the references, I have put the citation, right? So you can see the reference, the particular paper in which this particular topic has been discussed. Right. Similarly, different models like AI model have been employed exhaustively, right? Among this renewable energy sources. So ML regression model is there, and let's see. So I put this information just to help you to understand the present scenario, right? So what are the different parameters which can be optimized? What are the different outputs can be optimized? And the optimization can be possible right from design stage. So when you design a component, you have to optimize different parameters. When you manufacture a component or the equipment, you have a lot of parameters coming, right? So you have to optimize the parameter in order to ensure the component is optimally manufactured. And then again, if you go into the operation, when the wind turbine is being operated, the power production has to be optimized. So these are the various domains of renewable energy sources, wherein you can apply this AI and ML model. But still, there are challenges in application of AI and ML model, right, in renewable energy sources. So data acquisition, if you don't have data, you cannot use AI and ML model, of course, right? Instead of going to do with the help of AI and ML model, you can directly do by simple calculation manually, right? Simple Excel tool can be helpful in performing a simple linear regression or logistic regression model, right, of two variables, independent or dependent variables. If you have a very limited data, our Excel tool can be able to do that. You know that, right? You do that. Normally, you are doing that for a project of your own, right? So in order to have very good accuracy, the better accuracy, you need to have a large amount of data, right? Then only the application of AI is possible, of course. And then key variable selection parameter. So again, the challenge is that there are multiple data. For example, if a big compressor is running, which is having around 30 to 40 parameters, right? Different temperatures are measured, different vibration levels are measured, different pressures at different locations. It's a big, huge compressor unit, right? So monitoring all these parameters and optimizing the performance is really a big challenge, right? Even the AI model will fail if it is not done using a large amount of data, of course. So selection of key variables, again, is a big challenge in this optimizing the performance of renewable energies. Modeling of various faults and simultaneously is another important problem, right? So you cannot be able to check different components simultaneously, right? And cause and effect of that particular fault, right? What is the reason for that particular fault, right? And there are different faults, right? So you have to be able to identify the root cause for various causes, of course. So again, there is a difficulty in modeling various faults and their causes simultaneously, right? So, but these problems are being overcome by developing robust AI/ML models, right? So that is the point of research at this point of time. And stability and generalization in predictive model. Yeah, predictive model. What the predictive models do? Model will give you an answer now, and if you change some parameter, or set of data, the model may not be give you the same answer. So the stability is still is a question. And then security and protection against the data. Of course, this another cyber security has to be a part of this, a technique tools. It should be built with the cyber security, cyber war, and performance and explainability issues still is there. So understanding the system is this is a huge Herculean task, right? So accordingly, you have to develop a eminent model. Still, there is a gap between these two. And then energy storage, we have discussed already, right? So we have a limited battery capacity, right? You can have a battery of around, the size, the floor size, maybe around 1,000 square feet, more than that, 2,000 square feet. So again, if you keep on increasing, in order to increase the capacity, it will occupy the large space, and it is a heavy loss. There will be transmission losses, and the maintenance of battery is another problem. So again, the energy storage and grid integration we have already discussed, right? So though we explore the AI technology in producing efficient renewable energies, but still there are unresolved or the issues persistently growing. So we have to address all these growing tech challenges in coming years by developing technologies, right? So another, apart from AI, we have to have a base core technology. So for that, we need to have a very good material advancements are going up, right? So we are going for a graphene battery. We are going for a sodium battery, right? We are going to replace the lithium and battery in soon. And even we are going to replace EV maybe within 15 or 20 years time with hydrogen. Hydrogen is coming up. Hydrogen is more sustainable than even EV, right? So EV is now coming. वो आते आते बंद हो जाएगा. What I feel, that is my personal, because EV is coming up, but it's not geared up. It has not come up to what is expected. But still, by 2030, EV may reach to a level wherein the fossil fuel vehicle sale will be trimmed off, right? And then slowly the more sustainable technologies to be evolved, and manufacturing process to be improved, right? So we talk about 3D modeling, 3D printing, right? The components are being manufactured using 3D, right? Even as a big house is being printed, big house can be manufactured. We can have our own house which is purely based on 3D printing. That is possible. So we have to have the technologies to be evolved, right? So in order to meet the challenges which the renewable energy sources face, right? So I think that's it. I just like to wind up with this. At the end, I have put the research papers which are relevant to this particular application, right? The application of AML model in renewable energy sources. I think I can share some part of this slide, not all, with the organizer. So I think you'll be able to get some of the information from these papers. So if you want to do real research or some project in this area, I'm sure that you will not regret later on, because it is going to give you fantastic output. That's what I would like to say with these few words. The short lecture, I would like to stop over here. If you have any questions, you are most welcome to have some interaction, so that I will also learn something from you, because I guess that you are also equally experienced and knowledgeable as far as this particular topic is concerned, maybe, right? So thank you so much.
Thank you so much, sir. It was a wonderful session. And as sir said, it is a time for a question answer session. So please feel free to ask any question, or you can type in your chat box if you're having any question. Please ask.
Yeah, thank you, Mr. Sabasachi. Sorry. Yeah.
Thank you, sir. Thank you. So anyone having any question, please ask.
So I think they can also put the question into the chat box, no? If they are willing to do.
Yes, sir. Yes, sir. They can
Yeah.
type in chat box also if anyone having. Sir, one question is there from Ubik Sarkar. What is the role of AI for site selection, forecasting, and evaluation?
Yes, as I told you that you cannot select the site randomly, right? And you need to go with the different parameters. For example, if you want to select the site wind for setting up wind turbine, so you need to know how much wind velocity for not today, for not tomorrow, for the whole year, right? So that cyclic, it has to, the wind velocity should exist. There should be constant wind velocity should exist in order to produce a significant amount of electricity. So when you select the site, you have to see the parameters, the input parameters like wind velocity, and then weather. So whether that particular site has got the rain, right? So the how much, what is the rainfall? Otherwise, you cannot put when where there is a rain, the velocity will be hampered. Wind velocity will be stopped. If the rains throughout year is no meaning of putting your wind turbine over there. So the power production will not be there. The same case with your solar panel. So the site is very important. So what are the different input parameters? You have developed your AI model, right? You have written some algorithm. You have algorithm is written based on some transfer function or some equation, right, by which you'll be able to solve, right? So that is what you call modeling, right? So you have to do some modeling. You have to come up with some modeling. Then once you do modeling, that with the available data for the last maybe past 2 years or 3 years, data of the particular wind velocity or the solar intensity or the rainfall or the humidity. So all the weather report, weather input data can be given to that particular model as input parameters, and then model is trained and you will get the output. For example, the optimal location, right? So you just select, you give the data for 4 sites, site A, B, C, D, and you feed the data of these all 4 sites, you will be able to get the best site. So the A will give you the site B is the best one, right? So you see the chat GPT can give you, right? So based on selection, but that is the chat need to have some data backup, right? So the availability of data is a big challenge in site selection or whatever. If you don't use this AI model, you can do manually. What you have to do, you have to do manually. You have to visit the site. You have to check the past history of the data, right? And then you have to see, you have to check the weather report manually, and then you have to come up with some idea of selecting a best site, right? So instead of doing that, the A and ML model will be able to do it at no cost. Yeah, so that is one question.
Sir, sir,
Yeah,
furthermore, one thing, sir, can we use Bayesian network
yeah,
model
yeah.
or the game theory for this
You see,
purpose?
you have written, can we use Bayesian theory? Yeah, of course. You see, again, Bayesian theory is widely used in A&ML model. It is a part of statistical modeling nowadays, because systems are dynamic in nature, right? Nowadays, if you do a static modeling, right, steady state modeling, sorry, for example, in modeling you have 2 types of modeling. One is a steady state modeling, the other is transient modeling, dynamic, right? So you have to model the equipment considering the dynamic changes, time, right? The time is another important things, right? So you have to consider the time, that how the parameter changes with respect to time. So dynamic changes, what you call transient modeling. So in case of transient modeling, of course, this Bayesian model, the game theories are going to be widely used as a part of a model. There are papers available in this actually. So you see, you can integrate n number of techniques. There is always possibility of integrating n number of techniques, right? As I shown you the previous slide, right? So when you integrate it, you will get the advantage of that particular technique, right? The Bayesian is very good tool which can help you to add the conditional probability of some events. So that is the best way of considering uncertainty in your modeling. So Bayesian is really good tool, and of course you can use this. Of course, the game theory also as well. Yeah. So all kind of experiment. If you try it, I'm sure that you will not regret. So that is a thing. And one thing, when you integrate all these techniques, the model will be a complex one, and you have to. That is another challenge, right? So the complexity of the model to be addressed later on. Accordingly, you have to develop your algorithm so that it takes a little time to give you the output of the particular model. So that is only the difference. Otherwise, you can go ahead with using any kind of models. So there are papers available in this game Bayesian and game theory and all. You use. So there is another question. Yes, sir. Okay, I think that is fine, right? That is not a question. Yeah, so that is very important. As I think Mr. Ghosh has mentioned, no, mathematical model is the key, right? So we talk about A and ML model, but ultimately, as I shown you, the simple, equation y equal to mx plus c, right? That helps to predict the one variable vertical axis, which is coming in vertical axis. So that is the very important, assignment you have to play. So developing an equation and use this AI model, right? AI and ML model. So all this artificial intelligence are developed based on some so biological process. Right? We just got ANN based on our human brain function, and we got a genetic algorithm. Evolution theory. The other part of you can also use evolutionary theories, right? Like genetic algorithm. You might have heard about. You might be using, of course. GA is there, and particle swarm optimization, PSO is there, and colony optimizations. There are n number of new evolutionary algorithms have been developed, right? So you can also integrate AI model with this GA and PSO evolutionary algorithms. So that is also one of the area you can explore to optimize the engineering system. Yeah.
Thank you so much,
Thank you.
sir.
Thank
So, anyone having any question, they can ask.
Hello, I have one small question. Um,
Yes, Sudeep sir. Yes, sir.
yes.
Yes.
Regarding hydroelectric power generation, okay, we use basically dams and reservoirs on running rivers so as to elevate the head and run turbines. So in these areas, how the AI and ML can optimize the power generation? What do you think?
Actually, that is used actually for optimizing the power output. How much is the head? That the head is very important parameter for you, right, to decide. And then the density of water or whatever the input parameters, right? So there are research papers available in this area where you can optimize the output of the turbine actually, right? So the turbine which you produce that. So again, you have to identify the input parameters, all these parameters, right? So what are the requirement of the head, what level of the water it should fall, right? So the head and that the kinetic energy or whatever, right? So the input parameters selection is very important as far as the equipment is concerned, be it a hydropower plant or be it a wind turbine or solar or whatever, right? So we need to work on that. That is what you call the domain expert, right? So since you are expert in designing hydro dam, you are the right person to use this AI model for your application, right? So you have to select the input parameters, that is that, and then accordingly you have to develop an equation and integrate with the AI, and then develop model and collect the data. That is another. You have the data of hydro dam. It's very good. If you don't have data, don't go with the AI model. Use only conventional equation. Have data, then go with AI, and then you can be able to get really a good output of this power production. Right, Sudeep sir?
Thank you very much, Lokanand sir.
Thank you, sir. Thank you, Sudeep sir.
For your valuable insight.
So, another question is, can we use knowledge-based expert system
you see what do you understand about knowledge based expert system? Actually, you see, all expert system, right? Fuzzy logic, you can call it as I told you, right? There is a model which is integrated with the fuzzy logic is there, and you can just integrate fuzzy logic with the AI, and that is what we call AFNIS system. Of course, there is a possibility to integrate any type of knowledge-based expert system with any kind of AI model. So the thing is that when you integrate it, the speed, what time you will get the answer, right? When you compare the algorithm AI models, right? When you compare the LTM, 1 minute, I'm just to get a call. Sorry. So that's it. When you integrate, it becomes complex, and you have to address the complexity by way of writing a simple algorithm. So that is only the challenge. Otherwise, you can go with integrating any kind of expert systems. Of course, it is being researched widely. You can go in with that.
Thank you so much, sir. So, as we come to the end of today's enlightening session, we extend our sincere thanks to Dr. M.K. Loganathan, sir, for sharing his expertise on the application of AI/ML in the renewable energy sector. Your insights have been incredibly informative and thought-provoking, sir.
Thank you.
Now,
Thank you.
a certificate of appreciation is going to be presented to Dr. Loganathan, sir, which will be shown in the screen.
Thank you
Thank
so
you
much.
so much. Thank you so much, sir.
Thank you so much for your time, patiently listening to my talk. So anyway, so I think there's a lot of scope for this research activity. I know AI and ML we talk about, but what is the problem? No, we have to utilize at the fast pace because the technology is changing fast. So those who are really interested in doing research should publish some few papers. Do that is a starting point of this research. So at least one paper of each of the faculty members from this institution to produce at least one paper in the application of AI and ML, not necessarily for this renewable energy, but maybe in their respective field. So that will definitely add, their credibility, academic credibility. Thank you so much.
Sure, sir. Sure, sir. Thank you so much, sir.
Thank you.
And
Thanks.
a heartfelt thank you to all the participants for their active participation throughout this FDP. Now it is my privilege to invite Dr. Rajdeep Chakraborty, Dean of R&D, RERFGI, to address us and share his valuable insights as we conclude this impactful faculty development program. Rajdeep, sir, up to you.
Hello, am I audible?
Yes,
Hello.
sir. Yes.
Okay. Thank you, Sabasati. Thank you all. Good afternoon, everyone. As we come close to this insight and inspiring the event of recent trends in renewable energy sector, so it is my privilege and pleasure to deliver the vote of thanks on behalf of the organizing committee. So first and foremost, I would like to express the deepest gratitude to our esteemed speakers, your expertise, your thought-provoking insights, and your passion for the sustainable energy have truly enlightened us. So you have not only broadened our understanding, but also energized our commitment to a greener and cleaner technology for the future. So heartfelt thanks to all the participants and attendees of this institute and from the other institutions. So your active engagement made this event interactive and meaningful. So I must thank to our principal, Dr. Sudip Bosak, Registrar Mr. Suprabhat Basu, Dean Academics, Dr. Shubhankar Ghosh, for their constant support and in organizing this event. So we are also immensely grateful to our admin staff, especially Mr. Rajiv Kumar Shah and Mr. Suresh Chandra Jana, whose generous support made this event possible. And lastly, to our organizing team, especially I must thankful to Mr. Sabasati Mukherjee, Mr. Rahul Das, Mr. Minmoy Das, Mr. Abhi Ghosdar, Mr. Somnath Mukherjee, Mr. Shobhit Sarkar, Ms. Lavani Nandi, Ms. Abhilasha Shaw, and Mr. Rajarashmi Chandrasekhar for your support, your tireless work behind the scenes ensured everything ran smoothly and professionally. And finally, let us remember the real success of this event will be measured by the actions we take going forward, and we may continue to learn innovative and collaborative toward our world powered by the clean and renewable energy. Thank you. Thank you very much.
Thank you so much, sir.
Thank you.
So before concluding, please note that the feedback link will be shared shortly and has been already shared in the chat box, and it will be shared in the WhatsApp group also, which is mandatory to receive the certificate. And again, thank you all once for being a part of this FDP. Thank you so much and have a good day. Thank you.
Thank you. Thank you all.